Now, if we look at the third part of our principles in Evo Devo, we can think about how modularity results from the existence of multiple gene switches. We call them gene switches. And so gene expression depends on the type and concentration of some kind of an activator or suppressor present in the body of the organism, in the cell of the organism. And as a result of this, the same gene may be switched on or off at different times or at different places during development, which ultimately can have consequences both in the negative sense and in the positive sense for whatever organism is developing. So then we can move on and take it a step further and look at how this modularity then allows for the expression of developmental control genes in different amounts at different times and in different locations during development. So we're looking at things such as heterometry, which is the amount of the gene expressed, for instance, in beak size of birds. That's heterometry or gene amount expression. In other senses, you can also have heterochrony, which is gene timing. So in the necks of giraffes, it's not that there are more neck vertebrae produced, but it's that the genes are allowed to be expressed for a longer period of time, and therefore the neck vertebrae are longer. That's why giraffes have longer necks. And then finally, we have heterotopia, which is just variations in the spatial pattern of expression within organisms. And you can see it over here shown in, it looks like limb development in probably some kind of a bird, I believe. Yeah. But yes, limb development. So spatial pattern of expression, gene timing, how long is the gene being expressed, and gene amount, how much of the gene is being expressed, all falls under modularity. And so this is the key principle of Evo Devo number 4. And then we can move on to number 5 then, where we can look at how existing genes that are already present, so think about like tinkering again, can be recruited for novel functions through certain evolutionary processes. So one example is the distalis gene, which normally is expressed in arthropods for limb development, but this distalis gene can also be co-opted for other uses. For example, in butterfly wings, it's been co-opted to produce eye spots. So it's this very interesting situation where you have certain genes that are already present in the system that you can then co-opt for other uses, which is very, very phenomenal because it's, once again, going back to that tinkering concept. You're not creating something completely new out of thin air. You're simply taking something that's already present in the system and then altering it a little bit and using it for something else, which is quite fascinating in a sense. So ultimately, developmental systems can be very sensitive to environmental cues. And this, of course, falls under the key principle of Evo Devo number 6. And one example is the lady beetles, aka ladybugs, these little insects over here. And the ladybugs are really interesting because the temperature during the development of a ladybug or lady beetle affects the coloration and the number of dark spots on its shell. And so this then again falls under certain concepts such as phenotypic plasticity, where environmental factors can affect the same genotype to cause different phenotypes. So phenotypic plasticity, again, is just one single genotype producing multiple phenotypes as a result of certain environmental factors. So in this case, that environmental factor for ladybugs is temperature, but it can be for other things as well. So ultimately, what's really fascinating about these concepts is that they're all linked together, and modularity, as well as extensions of modularity, and co-opting and tinkering ultimately can lead to that great diversity we see today in many organisms. And so it's very important to sort of get a basal understanding of these concepts in evolutionary ecology as well as evolutionary and developmental biology. So Evo Devo is often a key concept that shows up on the exam, so it's best to get some basic knowledge of it and then ultimately get a better understanding of it. And I think that's all I'm going to keep it at for now. Make sure you study your notes as well to see what information your professor is asking you to know. But I appreciate you viewing this video, and hope you found it useful. And as always, best of luck studying, and I will see you in the next video. Take care.